Hi, welcome to the Unit 8 Day 2 Example Problems video. In this video, we're going to go over Example Problems Part 1. Alright, so to begin, in the Part 1 examples, we're dealing with solutions being made from a solid that's dissolved in water. Now, all of these are solids because in these example problems, you're dealing with metal hydroxide bases. Remember, metal hydroxide has a metal and a nonmetal, so it's an ionic compound. And we know that ionic compounds are all solids. So metal hydroxide bases are all solids. And when you make a solution of them, you weigh out your solid and then you dissolve it in enough water to reach the volume of the solution that you want. So, in all of these problems, we are given the mass of our solid, of our metal hydroxide base, and the volume of the solution that we're aiming for, and we're using that to calculate the concentration of that solution that we make. Once we have a solution, then we use the amount of hydroxide, in the case of bases, that are produced to figure out the POH and the pH. Okay, so let's begin. In this problem, it says 1 gram of barium hydroxide is used to make 250 milliliter solution. So they're giving us the mass of the barium hydroxide and the volume of the solution. And they want to know what's the concentration. Now remember, when you see concentration for these problems, there are different forms of concentration, but for these solution problems we use molarity, which is equal to the moles of the solute. In this case, that would be moles of barium hydroxide, so that's the thing that's getting dissolved, our solute, over the liters of solution. So the volume of solution in liters. So let's look at the information we have. We have the mass of barium hydroxide, but we need the moles. So we're going to have to convert from the mass to the moles. And we have the volume, but it's in milliliters, not liters. So let's quickly do that conversion. Remember, to convert from milliliters to liters, you divide by 1,000. So we're going to take 250 divided by 1,000, and that will give us 0.250 liters. So we right now have the volume in liters. We just need to get the moles. So to get the moles, we're going to take the mass of barium hydroxide and convert it to moles. And remember, for that conversion, we're using the molar mass. And I've already calculated the molar mass using the periodic table. So the molar mass of barium hydroxide is 171.34 grams. All right, so we're going to take our given 1.00 grams of barium hydroxide over 1. And then we multiply it by second fraction. That second fraction will come from the molar mass information, of course. Since I'm starting with grams and I want to cancel out, that means grams are going to go on the bottom. So the 174.34 grams go on the bottom. 171.34 grams. And then the 1 mole goes on top. Grams cancel out. And when I plug this into my calculator, I get 1 divided by 171.34. And that gives me a mole of 0.00584. Okay, now that I have my moles, I can go ahead and calculate my molarity. So my molarity will be the moles, right? So the moles go on top, so 0.00584 moles of my barium hydroxide over the volume of solution, which is 0.250 liters. And that gives me, if I divide that by 0.25, I get my molarity to be 0.0233 molar. Okay, so that's the first part done. So I have the molarity. Now they're asking me to calculate the POH and pH. So let's talk about that for a second. Remember, the pH and the POH comes from taking the logs of the concentration of H plus and OH minus respectively. So in the case of POH, it's going to be negative log of OH minus. So whatever comes after the P is what you're going to be taking the log of. Now, since we're dealing with bases, it's easier to start with the POH and then find the pH from there. Okay, so What we'll need is the concentration of OH minus, but I have the concentration of barium hydroxide, right? So how do I get the concentration of OH minus? When you're dealing with a strong base, remember when you're dealing with a strong base and you dissolve it in water, what happens? It ionizes, it breaks apart into its ions. So it's going to break apart into barium ion and in this case 2 hydroxides. So that means for every 1 barium you're going to produce 2 hydroxides. So that means that the ratio here is 1 to 2, right? So since the ratio of barium hydroxide to OH minus is 1 to 2, the concentration of the hydroxide is going to be double whatever the concentration of the barium is. So the concentration of OH minus in this example, because there's 2 hydroxides for every 1 barium hydroxide, it's going to be 2 times this number. Okay? So the concentration here is times 2, 0.0467 molar. Now, one quick thing I want to note that if you're looking at that and you're like, oh, wait a second, okay, that kind of makes sense. Where did we get the 2 from again? The 2, you can tell that there's 2 here because in the chemical formula for barium hydroxide, the hydroxide is in parentheses, there's a 2 on the outside. That means that there's 2 hydroxides attached to that barium. And when you put it in water, it breaks apart into the one barium that you have and then the 2 hydroxides. Okay, so now we have the concentration of OH minus. That's all to get the pH. POH. So the POH will be negative log .0467 molar. And to type that into the calculator, we're going to hit the negative log. My answer was saved, so I can just hit second answer, or you can just type these numbers in if you want. Close parentheses, enter. And then I get the pOH to be 1.33. All right, finally to get the pH, so that's the pOH. The pH is going to be 14 minus the pOH. Now the reason why that is, if you go back to the Unit 8 Day 1 notes, you remember you saw the pH and pOH scale, they're kind of inverse of one another. And if you look at the pH and the pOH scale, okay, so they go from 1 to 14 typically. Of course they can go beyond that, but it's typically 1 to 14. Now if this is the pH scale, the pOH would be opposite of that, sort of, or the inverse, I should say. For the pOH scale, this would be where the 14 is, and this will be where the 1 is, okay? So they work sort of opposite to one another. And, oh, sorry, this should be a 0, not a 1 there. 0, okay. So what happens is if you add up the pOH and the pH, they should equal 14. So on the flip side, so that's pH plus pOH equals 14. So on the flip side, if we're solving, trying to figure out the pH from the pOH, we would subtract both sides by pOH, and we get pH is equal to 14 minus the pOH. And that's where that comes from. Okay, so what we're going to do is we're going to take this number, 14 minus that number, and we get 12.7. Okay? So that's the pH. So here's our answer for that problem. Let's do it for example 2. So in this problem, we're given the mass of a metal hydroxide base, so we know it's a solid. So we have 0.0895 grams of lithium hydroxide, and the volume of the solution is 100 milliliters. Remember, the first thing we want to do is convert that to liters, so I'm going to do that by dividing by 1,000. And we want to use this information to find the concentration of lithium hydroxide. So remember, the concentration will be the moles of the lithium hydroxide over liters. So for concentration, it's equal to the molarity, which is equal to the moles of lithium hydroxide over the liters of the solution. Now we already have the liters, we just need to get the moles. To get the moles of lithium hydroxide, we need to convert this mass into moles, and we've done that before many times. So we'll take our amount of our mass here, 0.895 grams over 1, times the second conversion factor, which is going to come from the molar mass. So since I have grams here, I'm going to put the 23.95 grams in the bottom. And just to remind you, I got this molar mass by using my periodic table. Okay, so I already calculated that for us there. Okay, so 23.95 grams, and then 1 mole goes on top. Grams cancel out. We're doing 0.895 divided by 23. So 23.95. Okay, and that gives me a mole of 0.0374. Okay, so we have my moles of lithium hydroxide. Now that we have the moles of lithium hydroxide, we're going to take the 0.0374 moles of lithium hydroxide to calculate our molarity and divide it by our liters. So 0.0374 divided by 0.1. And we get 0.374. Okay, so that's our concentration, the molarity of the solution. Now we need to find the pOH. So to find the pOH, we're going to use negative log concentration of OH minus. Now, to get the concentration of OH minus, we have to look at how lithium hydroxide ionizes. When you dissolve lithium hydroxide in water, it's going to break apart into lithium ion and a hydroxide ion. And you only have one hydroxide ion, and you know that from the chemical formula. So do you actually have to write out this balanced chemical equation? No, I'm just showing the ionization equation for you so that you can see it. But what you really want to look for is how many hydroxides that are there. And remember, this process only works when it's a strong base, because when it's a strong base, it completely breaks apart into its ions. If it's a weak base, they're in what's called equilibrium, so not all of it will break apart. And so for weak bases, you actually have to use something called the KB. We're not going to see that here, but I just wanted to let you know that for all these problems, they're strong bases, and the reason why we can use this relationship, the number of hydroxides in the base, to get the concentration of hydroxide from the concentration of base, is because it's a strong base. So that's the only point I was trying to make. So what do you really need to know? Once you have the molarity of your lithium hydroxide, if there's only one hydroxide in lithium, that means that there will be only, it's a 1-to-1 ratio, so there's only one hydroxide that you can form, and so therefore the concentration of the lithium hydroxide will equal the concentration of the hydroxide. So we can do pOH is equal to negative, the number that we got here, negative log of 0.374 molar. So again, we hit the negative button first, negative, then we hit our log. Once we have that, we do, my answer was saved from before, so I just did second answer. And then we get this as our pOH. All right, now to get our pH, it's going to be 14 minus the pOH. So it's going to be 14 minus 0.427. Oops, what am I doing here? 14 minus 0.427. And we get 13.6. Now, final note here for these problems. So the overall process is you take your mass of your base, use it to find your moles. You plug your moles and your volume of solution that you've converted into liters if you need to. You plug your moles and your volume into the molarity equation, so moles over liter, to get the molarity of your base. Once you have the molarity of your base, you're going to use that to find the concentration or the molarity of your hydroxide, your OH minus, so you can calculate your POH. The thing to note for that is that the concentration of hydroxide will depend on the number of hydroxides in the base. So if your base, like lithium hydroxide, has 1 hydroxide in it, then it's going to be the same number. But if you have an example like with barium hydroxide, the concentration of the hydroxide is going to be double what you got in the previous step. It'll be double the concentration of the barium hydroxide because you have 2 of them. So once you have your concentration of OH, then you plug that into the POH equation, negative log of concentration of OH, and then you do 14 minus POH to get the pH. All right, that is it for this video. Oh, one last thing I wanted to remind you guys of is that these numbers should all make sense. Since these are all bases, the POH should be a very low number. Remember, for if it's a base, the POH will be less than 7. But on the flip side, the pH, if it's a base, will be higher than 7. And we do see that here. So the POH for this base is 1.3, that's less than 7. The pH is 12.7, that's greater than 7. Same thing for this example. The POH is 0.427 and then the pH is 13.6. And you can also see that for the pH, for example, 13.6 and 12.7, that would classify these as strong bases, which is what we're dealing with here. Right? Remember, these are all strong bases that you're using in these examples. All right, that is now completely it for this video. You've got some practice problems to do, and check your answers. Have a quality day.